what had been there before.
Oh.
You're not squeezing it.
Okay.
You're replacing.
When and if you just and it. When
Okay, now we are ending it with what? Okay, now that's the
you
look.
end it with all ones.
Okay, if you end it with all ones, where in this position, what happens? If you end it with all ones, what happens?
Get everything that is there.
If you end the 0 with a 1, what do you get?
1, 0,
0. If you end 1 with a 1,
One.
1.
so it didn't get you any. Right. If you end it with all ones, you end up where you start. Okay, but you know, that's the, okay, therefore you OR it with what? All ones. Okay, fine, good, all right, there you go, you guys are solving. Okay, so we OR it with all ones here. We know the position, otherwise we cannot do anything. Right? So we call that mask, you know, big patterns are usually called masks. We'll call that mask 1. Obviously we haven't brought home the bacon yet, right? Or anything is a little different. Okay? Now, however, let's be careful here. What about this? We cannot, remember those things cannot be changed.
But OR doesn't carry over.
What?
Doesn't, or I don't think OR carries though.
What do you need the carrier for? God forbid. You
No,
don't
I'm
need
saying it doesn't carry.
the- Don't. I mean,
So why do you have to worry about it changing if you're only worrying about the bits individually?
yeah, right, but you know, there's stuff in here. In other words, every bit has to be assigned to some value. Remember programming, right? We cannot assume. Yeah.
If you do all zeros in
If you do all zeros here, right? Because we have to assign that value. We cannot leave it to nature. Because if it's garbage, then it will damage what we have here. Right? If we OR anything with 0, that remains itself. The same way as if we AND anything with 1, then there's the duality of Boolean algebra, right? Remember all this stuff. Boolean algebra, again, is an algebra with 2-valued variables. Okay, so we are ORing, so in other words, our first instruction here is OR register 5 with mask 1. So the result of that is that in register 5, you get what?
X, B,
We get x's, right? Same as before, right?
and all ones in the middle.
And all ones in here, thank you. Okay.
Now, you and with what
Right.
you want.
Now you end with what? Right, we don't want it changed, so that's, now we use your idea
Zero
from
for
before,
X.
right? We end that with all ones here. Because if we end it with all zeros, they'll never come back. Alright. And here,
1, 0.
right, our favorite button. And that again, this is presumably mask, this is mask 2, here. And that is the same with all the register 5. And so again here, in the register 5, whatever was there before. And then that pattern will wanted it, right? And such.
So the operand would be and R5 with mass two.
Right, and register 5, also the Any questions? Now, anyone who is not with me should be asking questions. So I assure you, if you have a question, then at least 3 other people have the same question.
Why do we need the passport?
Well, do it your way, do it with one step. Show me how to do it. That's the best way for you to see that you need a 2-step operation. I mean, what would you do, let's say?
Because you need to clear.
Just keep the passport and go to the last 2.
Well, what happens, okay? Let's say we skip my reasonable
Because
question.
you need to clear it, that's what the thing.
If we do that, then, you don't know what's in here. In other words, since you don't know what's in here, right? If you do the mask 2 thing, you end with the, let's say, whatever have you. Where's mask 2? With this one, right? And let's say here you have 0, 0, 0, 0, then you'll end up with all 4 zeros instead of replacing, right? So you're dependent on what's here. There's 1 chance in a million that it will work out.
But there's that
And you have to
one.
luck out.
Hey, you never know.
And you never know, it's right. But it's better to be going for a lottery than, this sort of thing.
Is that how all computer programming works?
What? Okay, guys. So do you see the need for that? Now, again, by the principle of duality, you can flip everything you want. You need to flip everything you want. In other words, the masks and the door, and you will come up with the same result. Right? That's what I'm saying. Insert a pattern into a non-addressable part of the word. That's the illustration. Every which way. So, way number 1, done. Try to flip everything, see how that works. See whether you can do this. Whether you can do that. Mask 1, mask 2. Yeah. But that would work. I mean, without this would be an X again. So you don't care what the intermediate value is here. But whether that would work. And why? Why yes, why not? Okay? Then, so you have one subset of ways of doing it. In other words, global operations, you'll see how that works. Then, use what we would something like that. Look for an operation like that works with a variable length bit fields that I introduced last time. Okay? And there you can do it in 1 step. That's the nice one, with 1 instruction. Right? You can do it right there in a general way with a single instruction. Then you always going to do it with rotate, do it with a rotate. And how do you express yourself? Use the pseudo-assembly language. You might have been taught that in your assembly language course or anything else. In other words, the way you would work with the C bit by bit. Let's say for I equals 1 to, let's say, N, do, and shift, register 1, left. That type of thing. Bit by bit. And so on. That's what you do. In other words, I don't assume in this course your knowledge of any specific assembly language. I assume your familiarity with assembly language. And so you use what you know to do that. Okay, so you have that. I mean, if you want to suffer, then you can do it also with logical shifts. But I would say you'll have enough using rotates. Now, don't forget the rules of the game. The rules of the game are you cannot test that bit. That's the only one you can test, that's the only one you can set, that's the only one you can reset. That. Okay? Assignment. Which doesn't act as assignment here, it acts as a leftmost pair. Okay? Questions? All right, let's take a break and then we'll go on with that.